Diary, hello. It's Sunday, the 12th of July 2020, and today I'm going to talk to you about temperature sensors, and in particular the sensor that we've bought from IOT 4 Limited, which is going to measure the temperature of the water in our immersion tank. So I don't have an exact. This has come about because the existing sensor, which is made by Smarthome, isn't working correctly. So I'm going to show you an equivalent sensor, but not the same sensor, and it's here. The equivalent sensor being the fact that we currently have a Smarthome TH16, which is a ESP8266 based sensor, so a microcontroller based sensor, running the TAS motor operating system and connected to a probe which looks identical to this, because it is identical to this, to measure the temperature of the water in our immersion heater, but it's proved very temperamental. The code is maintained on GitHub, and when you have problems such as this, you can join the Smarthome forum, and you can also post questions or bug reports on GitHub, and then the maintainers will try and fix it. So we've been at this for quite a while. Nothing's worked. The sensor kind of works, it doesn't work, and so we were looking for alternative sensors. So the point of this video is to show you that I managed to find an alternative sensor. So this is an example sensor with a relay here and an ES8266, and the Smarthome version that we have is in a box with a jack, and in that jack you plug a sensor. So anyway, that doesn't work, so reliably, so we've had to jettison that. So instead what we've done is we've found this device here. So again, I'm going to put in the description, I'll put the where we got it from. So it's a mains powered sensor. All we've got to do is plug in an AC source here. It's got a probe which is not removable, so it's fixed into the box. So the probe isn't very long, so we're going to have to locate this within, obviously, say about 60 centimeters of the actual immersion heater, and then make the rest of the distance using a long mains lead. And in our early testing, it seems to work fine. So if we go to the laptop, we can hopefully see just about the fact that it's configured using a Wi-Fi connection. So when you buy it, it comes with a user ID and password here, and then you set up it broadcasts itself as a Wi-Fi network, so you connect to it, rather like a Smarthome device. And then you configure the Wi-Fi from that point to connect to your home network. So once you've done that, you reboot it, and then you just go to the DHCP IP address that's been grabbed, and that's what I've done here. So I've just surfed basically into it. Obviously I've changed a number of parameters, like the IP address parameters. It's using NTP for time synchronization, but more importantly, you actually configure the mqtt protocol so that you can talk to your smart home. So that's what I wanted to show you here, the fact that it's a fully working, I'm guessing, ESP8266 device, as was the Smarthome, but this seems to work quite reliably. So the overall plan is that we're going to use this device. Let's go back to the device. So that's the rather limited demonstration of the web interface. I don't want to show you too much more detail, just to show that there is a web interface. It works absolutely fine. So let's put that away. So the next thing I wanted to show you was how the proposed system is going to work. So we've been faffing around trying to get it working for some time, but just basically lack of time has made things just not happen. So hopefully you'll be able to see something of what I'm writing on this piece of paper. Basically, for historical reasons, even the most modern smart home systems still seem to use this blasted wiring box. And this wiring box takes inputs from a number of sensors, and just by sheer wiring, these sensors either are open circuit or closed circuit, and they sort of work in a sort of AND basis. So you can imagine you've got, I don't know, say for example, room 1, room 2, room 3 and water, and so not the water sensor like this, but we've got another water sensor that's strapped to the side of the boiler that we can't easily remove or do anything with. So these sensors work in the way that when they need demand, when they sense that demand is needed, they go closed circuit. So this wiring box has got a mass of wires in here. And when all of these demand requisites are met, then effectively there's a short circuit, and then your boiler can operate. And it's a very old system, and I don't really like it. And it's obviously been designed in the days before you could have a central CPU controlling everything. So we're having to try and modify that system in the following way. So what we've got is now the following. We've got at the top of the tree, we've got Samsung SmartThings and Demotic. And to take this very simple example, we're going to have our temperature sensor, which is going to go into the boiler, in addition to the existing water sensor that we can't really remove. So we're going to have a temperature sensor, which is going to be this device here. It's going to measure the temperature 24/7. It's going to report that to Demotic every 10 seconds. And we're going to write some code, either in Samsung SmartThings or Demotic, to control the actual boiler, the heating boiler. And what that's going to do, that's going to send an information to Heatmiser. So Heatmiser already has these inputs and is already making decisions based on those inputs via this bonkers old-fashioned wiring box in some regard. But we're going to override that. So for example, our Demotic system, which is running on a Linux computer, can actually ask our Octopus electricity provider for electricity prices for 24 hours in advance, and we can determine what's the best time to turn on our boiler. So the idea is we'll pick the lowest electricity prices within the next 24 hours. We'll look at the temperature of the water in the boiler, and we'll make the best decision as to when to switch on the boiler based on the electricity price. And we'll either do that with the programming language in Demotic or in SmartThings. But the whole thing rests on being able to reliably, continuously measure the water temperature. So we're back to this device. So this is from IOT 4 Limited. I will put a link in the description of the YouTube video, and the cost is about £30 or £40. And it took about a month to arrive. I mean, they said it could be COVID related, but it literally took over a month to arrive in the post. I think it was from possibly Romania. It was from eastern side of Europe. Anyway, it took a long time. So you have a bit of time to work out your programming before it arrives. Okay, thanks for watching, Darry.